Hi, let's take a few minutes to go over and familiarize ourselves with the OverOps Transactions dashboard. This dashboard provides folks in a DevOps, Ops, and SRE role with the ability to observe and understand both the reliability and performance of all transactions within a target environment and to drill down into any anomalies observed. OverOps automatically identifies all transaction handlers within application code. It does so that whenever the JVM or a third-party container such as Tomcat or JBoss passes control over to application code, OverOps automatically identifies that without requiring any form of manual configuration or instrumentation as a transaction handler and begins capturing information around both the performance and the reliability of that transaction handler. This dashboard shows us here in the grid all transactions within the target set of environment and applications that are currently being observed, and shows us exactly both the performance status and reliability status of each one of those. I can see, for example, that a slowdown is considered more than 60% of the calls into a target transaction are taking much longer than they did in the baseline period. That will be considered a P1 slowdown as compared to a warning where just over 30% of the calls are slower, but still the majority are within the acceptable time range. Then for each one of the transactions, we also are presented with their failure status. We can see those are okay, but in this transaction we see that 11 failures out of 69 calls, 15%, compared to what was less than sub 1% in the preceding baseline. So we definitely want to take a look at this transaction. So in the grid we see exactly how many calls to each transaction, the response time, the baseline response time, so we can quickly compare between the two, and the number of failures. Then we can, of course, in the graphs, see a visual representation of both the failures compared with the throughput calls, the volume of calls into the transactions, as well as response time, where we can see a drop in throughput and contrasted to that a spike, a negative spike in the response time. For each one of these statuses, it's very easy for me to click and just to be able to drill down and see exactly the cause of those errors. So I can jump into any transaction over here and immediately I'm presented with the actual errors causing this specific regression. I can see how many times they've happened, what percentage, and how many times. And I can see exactly the baseline period over here to the left compared to the right to the active timeline period. Again, enable me to very easily detect anomalies and observe what is acceptable behavior versus what is a slowdown. The same is true when I am to click a slowdown. I can jump in and I can see exactly. Here we have, in this red line shows us this is to the right is the active time, the last 12 hours compared with the last 2 weeks. And we can see that on average when we had spikes, we're spiking again. And we can see exactly what's causing it. With one click, we can jump into the OverOps Arc Analysis screen that will show us the complete source code, variable state, at the moment of slowdown across the entire call stack, as well as the state of the JVM and debug level log statements. So developers can quickly reproduce and understand whether or not the cause of the issue is programmatic or operational. Here on the top we have high-level labels that show us how many slowdowns are critical versus more benign, and then the failure rate. What constitutes a failure within a transaction is also can be defined within the settings dashboard, which is by default any uncaught exceptions, any critical exceptions, things such as null pointers, invalid cast, defect that should never be in the code and will almost in all likelihood impact the experience that a customer or the user of the system may encounter, as well as HTTP errors as well. Here at the top we can filter by specific applications, microservices within the cluster only focusing in, for example, on a specific application, a deployment, a server group. So we can, for example, if we're doing performance tests and we're comparing performance between one server and the other, or one or in a canary scenario, we're putting the canary cluster in the overall estate, we can very easily choose which servers or nodes or pods in the containers environment we're looking at, and also of course narrow this by specific transactions or transaction groups. So for example, show me only servlets, within the app group. And that is essentially everything that is user facing. So I can see I don't have any slowdowns here, but I do have ones that are encountering a higher than average level of failures, and I should probably take a look at that. You can see, show me the transactions that are slowing down the most, or for example, the ones that are failing the most. So I can take action. I can see, okay, these guys are failing the most, and I can also see that this is abnormal compared to their baseline. And of course, with just one click, I can jump into either the slowdown analyses or the failure analyses. So in short, the transactions dashboard enables anyone in an operational performance engineering and testing capacity to very easily see which transactions within the system are behaving in an anomalous manner, and from that point on, drill in, compare that to the baseline, and then use the overall capabilities to drill down into the Arc analysis screen and see the complete source code, variable state, and everything they will need to reproduce and understand exactly the root cause of that issue.